Hey, we're going to go over a little bit of the component form of vectors today. What you have been working on is heading and kind of the length that it would go, sometimes bearing as well with that, which is nice for navigation. But as you guys have been finding when you draw the picture, it can be a little more difficult to do like trigonometry with that, or to actually like figure out the different pieces in there. That can be a little more difficult. It makes it easier to talk about, but more difficult to solve some things. So what we're going to do today is establish how do we find what's called the component form, which will help us use all of kind of the stuff that we've been doing before. We can very easily apply then to vectors. And that's what we're going to do here today. So the key piece with component form is we have to learn two things, not too bad. There's something called the I vector, and the I vector just moves one unit horizontally, or in other words, it's moving one with a heading of 90 degrees, right? We would turn 90 and go directly to the right. Yeah, that's what the I vector means. And the J vector is one that moves with a heading of 0 degrees, and it moves essentially vertically or north one unit, right? That's all that that means. So if we wanted something in component form, we might say 3I minus 4J. What all that means is that, again, vectors can start anywhere they want to. So we start most vectors, if we are going to graph them in component form, we start that at 0, 0 in a sense. And then this just means go 3i, 3 horizontally, and go negative 4 vertically. So in other words, go down 4, right? So it's the same as graphing the point 3, negative 4. And you guys can kind of get the sense here, oh, okay, it's going to be the same or very similar to graphing points, that we can use some trigonometry with that. But there's where that vector would be, over 3, down 4. Yeah. So what I want you guys to concentrate though on today is how do we change from the terminology that we have been using into this new component form. So here's one example here. So we would say, I just kind of made up a few examples for you to work on translating those. So this one is 135 miles at a heading of 294 degrees. So what we'd want to do first is see, well, how, where is 294 at? So as we turn around here, there's 90 degrees, there's 180, there's 270, and so 294, I don't know, it's got to be an extra 24 degrees after that. So somewhere up here, is our 294 degree angle in that part. Yeah, that's our 294 degrees. We'll put that in like a pink or something like that. Yeah. And so that means our vector, again, we'd started at the origin. Whoops, let's not move the whole thing, just that endpoint. And it's moving at 294 degree angle there. And then it's, 135 miles long. So that is the length of that vector. This is 294. That pink so we can see that. That's what you guys have been drawing. You guys have been doing that part. Now to put this into component form, here's how we would do that. First, what we need to do is find the reference angle. So here, actually, we'll find the reference angle. You actually don't need to find the reference angle, but I'll show you that in just a second. And so here, 294, as I kind of already mentioned, the reference angle is going to be 24 degrees because that's what's extra. It's 270 to here, and then 24 more degrees this way. So to find the I and J components, essentially all we're doing is we're just making a little right triangle in this space here. Yeah, that's all we'd really be doing. So let's put in here, oh, there's our shapes. And so basically what we have is we just have a kind of right triangle in that space. Yeah, that's what we're looking at. I'll make it kind of yellow or something like that. Oops. So that's what we're looking at there is this triangle. We just have to solve that. And you guys know how to solve this. If I want this vertical component, I would do, the sine of 24 equals, in this case here, we do the sine of 24 degrees is equal to something, our y value or our I value, right? I is going up and, J goes up and down. So let me put that in there. J value, right, or J vector, over our 135, which we can solve. I just want to make sure that we emphasize that setup. If we did the cosine of 24, that would be the adjacent side, which I goes horizontally, and we would put that in here. So I'm going to show you here, just so I can grab the calculator. This would take 135 times cosine. That would give me the I value. So in here, let's hop over here. Just getting some pictures there. We can always hop back to Google on this one. Let's go 135 times the cosine of 24. And now, if you're using Google, it will automatically think you're using radians. So you do have to type in the word degrees if you want it to be in degree mode, if you're just using Google as a calculator. So that says it's 123 now let's go to 2 decimal places, 123.33. So if we go here, that would mean it's 123.33 I, right? Because we're working with vectors, so I means that direction. And so this way. And then our vertical component would be 135 times the sine of 24 degrees. So I'm just going to go in here. Oh, no, nothing like that. So let's go 135 times the sine of 24. Oh, I don't want to do that either. All right. Oh, we're in degree mode here. Okay, so then we can just hit enter because I'm in degree mode on this part. So 54.91 on there. So we put plus 54.91 J. Okay, so there's our component form. Now this isn't quite right yet. We need to make a final adjustment in here, and we need to make sure we're taking care of all our negatives, right? This is backed up to the left, by 123. So I should put negative 123, make this a little longer so we can see that. And we should also put negative, or I'm just going to change this to a minus sign, 54.91 J. So that's perfectly fine. We can do that. Okay, we have to make sure to make that adjustment. Now, I am going to show you one little secret for those of you who do watch the videos and don't just jump right into the assignment. You don't need to necessarily find the reference angle. You don't have to do that at all. If you want to, you can just use the 294 because, again, sine, cosine, and tangent, which we don't need tangent, but they will keep track of some of the negatives and stuff for us. Actually, these angles aren't in standard form, so no, we can't quite do that yet. That's for another time. But when we get to when this angle's in standard trig form, then we can go ahead and do that. So ignore what I was just saying before. We want to make sure that, yep, we do actually take these parts. I was thinking wrong. My mind was in a different place. So actually, there is no faster way to do that. We have to find the reference angle in here, and then we do have to adjust to make sure whether it's positive or negative. And in fact, I made a mistake here. Maybe you guys caught that. This is positive. Whew, man, I was thinking all wrong. Probably because normally 294 would end here, but we're doing it a little different. So this should be positive here, and there's our state up there because it went up, a vertical component for J. Boy, I should probably take a break right now. My brain's kind of stopping to work. But well, your guys' stuff, very similar to just what this was. Again, same type of thing. You have your amount, you have your 135. I put some of the extra stuff over off on the side. If you want to use those, you can. And then you just have to put the component form down here. If you don't want to draw it out, you don't have to. You can just do that by hand as well. But there's just a few questions on the same kind of thing, just putting them as I's and J's. So if you guys do have any questions, go ahead and let me know. Sorry about those couple of mistakes in there, but that happens sometimes. Otherwise, wish you guys luck. See you tomorrow.